Module 2, Foundations of Generative AI. Chapter 10, Exploring Neural Networks and Deep Learning. Neural networks and deep learning are the bedrock upon which generative AI stands. This chapter will venture into the intricate world of neural networks, shedding light on their role as the building blocks of generative AI. 2.1 Understanding Neural Networks. Neural networks are computational models inspired by the human brain's interconnected neurons. These networks consist of layers of nodes, each processing and transforming data as it flows through the network. The layers are typically categorized as input, hidden, and output layers. Deep learning refers to neural networks with multiple hidden layers, allowing them to learn complex patterns and representations from data. 2.2 Deep learning's role in generative AI. Deep learning has revolutionized generative AI by enabling machines to learn and generate intricate content. The depth and complexity of neural networks allow them to capture nuances in data, making them suitable for tasks such as image generation, text synthesis, and music composition. Chapter Y, Differentiating between supervised, unsupervised, and reinforcement learning. A key aspect of understanding generative AI involves discerning between different learning paradigms: supervised, unsupervised, and reinforcement learning. This chapter will elucidate these paradigms and their significance within the realm of generative AI. 2.3 Supervised learning. Supervised learning involves training a model on labeled data, where the inputs are paired with their corresponding desired outputs. The model learns to map inputs to outputs, enabling it to make predictions on unseen data. While not the primary focus of generative AI, supervised learning serves as a foundation for understanding the learning process. 2.4 Unsupervised learning. Unsupervised learning operates on unlabeled data, aiming to uncover patterns and structures within the data itself. In the context of generative AI, unsupervised learning techniques play a pivotal role. They allow models to identify inherent structures in data and create new instances that adhere to those underlying patterns. 2.5 Reinforcement learning. Reinforcement learning involves training an agent to make a sequence of decisions within an environment to maximize a reward signal. While not a direct driver of generative AI, reinforcement learning principles have been intertwined with generative models, enabling systems to learn how to produce content that yields positive outcomes. Chapter Z, Introduction to Generative Models. Autoencoders, Variational Autoencoders, VAEs, and Generative Adversarial Networks, GANs. Generative models lie at the heart of generative AI. In this chapter, we will introduce and explore three essential generative models: autoencoders, variational autoencoders, VAEs, and generative adversarial networks, GANs. 2.6 Autoencoders. Autoencoders are neural networks designed to learn compact representations of data. They consist of an encoder that compresses input data into a latent space and a decoder that reconstructs the original data from the latent representation. While autoencoders are commonly used for data compression and denoising, they can also generate new data by manipulating the latent space. 2.7 Variational Autoencoders, VAEs. VAEs are an extension of autoencoders that introduce probabilistic elements to the latent space. This probabilistic approach allows VAEs to generate diverse and realistic samples. VAEs are particularly well suited for capturing the underlying distribution of data, enabling smoother interpolation and exploration in the latent space. 2.8 Generative Adversarial Networks, GANs. GANs are a revolutionary framework for training generative models through a two-player game. The generator creates data instances, while the discriminator evaluates their authenticity. Through adversarial training, the generator becomes increasingly proficient at generating content that is indistinguishable from real data. GANs have achieved remarkable success in generating images, text, and even videos. As we venture into the subsequent chapters, we will venture deeper into each of these generative models, exploring their inner workings, use cases, and practical applications in project management contexts. A solid grasp of these foundational concepts is crucial for project managers seeking to harness the power of generative AI in their projects. Thanks for watching. Praise and calm.